Hi all, this is Varshini Murali and I'm going to tell you today's chapter is going to be squares and square roots. So this is our new maths chapter, squares and square roots, grade 8, class CBSE/NCERT. So before we start with the lesson, I would like everyone to do with the pre-assessment. Number 1. An integer multiplied by itself y into y is called. Number 2. True or false? 160 can be expressed as x into x for some integer x. You can write your answers in the comment below. Today's learning objective. We're going to define square numbers and we're going to apply the properties of square numbers to solve problems. Square number. What do you understand by square number? The number you get when you multiply by itself a square number. So, let me give you an example. 4 into 4 is 16. So, 16 is a square number. So, the number which is here is 4 and you multiply 4 into 4, you get 16 as the result, right? So, the answer is 16. So, 16 is a square number. Here are some examples you can refer. 0 into 0 is 0. 2 times 2 is 4. So, 4 is a square number. And so on. Perfect squares. Now we will be looking at perfect squares. Before we start, I want you to refer to the square root. This is the chart of perfect squares to 1 to 30. 30, yeah. So let's see what are perfect squares. When a number ends with 2, 3, 7 and 8 at its unit place, it is not a square number. So here are some examples. 132. Here 2 ends at its unit place. So it cannot be a square number. Even 28. 8 ends at its unit place. So it cannot be a square number. If a number ends with 1, 4, 5, 6 and 9 at units place, it can be a square number. It may be. Let's say an example, 60. So 60 ends with 6 at its units place. At its units place. So it can be a square number. But 15, even though it ends with 5, it cannot be a square number. So they use may. It can be. Sum of the number which ends with 5 and all, it cannot be a square number. Let's move on forward. Property of unit digit of square number. So we're going to see some facts of square number. So when a number has 1 or 9 in its units place, it ends with 1. The square ends with 1. So let's see an example. Here we have 9 as an example. It starts in the units place. So if we multiply times itself, like 9 into 9, we get 81 as the answer. So the square ends with 1. Let's see the another fact. So when a number ends with 2 or 8 at its units place, you get the square which ends with 4. Here, if we have 8 as an example, 8 times 8 is 64. It ends with 4. The square ends with 4, right? Let's move on forward. If a number has 3 or 7 in its units place, it ends with 9. So let's take an example of 7. 7 times 7 is 49, so it's end with 9. Even 3. 3 times 3 is equal to 9. The square ends with 9. Let's see another fact. If a number has 4 or 6 in its units place, then its square ends with 6. So if it's number like 4, it starts with its units place, then we multiply it times itself. 4 times 4 is 16. The square ends with 6. Even and odd squares. We're going to look at the even and odd squares now. So when a number is odd, its square is also odd. If a number is even, the square is also even. So 16 is a number. The square of 16, the square root of 16 is 4. Is 4 an even number? Yes. 25 is an odd number. The square of 25 is 5 to the power of 2. So is 5 an even or odd? It's an even number. Like that, we can identify if a number is an even or an odd. If it's even, we'll get an even square. We'll get a square which is even. If it's odd, we'll get the square as odd. Adding square numbers. If the sum of the numbers are consecutive from 1 and odd, so the square root of these numbers is the number of observation. Let me make you understand. Here's one example. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. You, instead of adding these things to get the result, now if you add, what it answer as? 49, right? Instead of adding these numbers, we can just count it all. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. So just count this number. Count along with me. 1, 2, 3, 4, 5, 6, 7. So basically there are 7 numbers, and if you write 7 to the power of 2, you get the answer as, which is 7 times 7, which is 49. So instead of adding these all, you can just go to an easy method, right? Let's move to another example. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 is 81. No need to do it at all. Just need to count the numbers. Count along with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get 9, and if we add 9 to the power of 2, which is 81. And so on. Now let's move to the next slide. Odd number of zeros. So if a number ends with the odd number of zeros, then it's not a perfect square. Let's see an example. 30. It ends with odd number of zeros, so it's not a perfect square. If we take 100, what is the square root of 100? 10. It is a perfect square. But if we take 5000, it ends with the odd number of zeros. It is not a perfect square. Zeros in the square number. If a number contains 1 zero at the end, so 2 zeros will have its square. It means the number contains zeros will double zeros of its square. Let me show you an example. 30. So see, how many zeros are there in 30? 1 zero, right? So if you double it, it becomes 2 zeros. If you take 5000, how many zeros are there? 3 zeros. If you double it, you get 6 zeros. Like that, we can understand, we can get how many zeros are there in a square number. 400. Here there are 2 zeros. If you double 2 times 2 or 2 plus 2, you get the answer as 4 zeros, right? So this is an easier method to see how many zeros are there in a square number. Difference of two consecutive square numbers. So let's find the difference of two square numbers consecutive. If you have the example here 4 to the power of 2 and 3 to the power of 2, we're going to first see the difference now. Now we'll see the square numbers of them. So let's first see 4 times 4 is 16 and 3 times 3 is 9. Now if you minus 16 minus 9, we get the answer as 7. Here 2n plus 7, 2n plus 1, which is 2 into 3, the second number, plus 1. So what is 2 times 3 plus 1? 7. 7 equals to 7, right? Let's see another example. We're going to find the difference of consecutive square numbers of 3 to the power of 2 and 2 to the power of 2. Now first let's find the perfect squares. 9 and 4. 3 times 3 is 9. 2 times 2 is 4. Now we're going to minus both of them. 9 minus 4, which is 5. And we're going to see 2n plus 1. 2 times 2 plus 1, which is 5. 5 equals to 5. Numbers between square numbers. We can find some numbers between two consecutive square numbers by finding the square numbers of any two numbers. So let's see how we're going to find square numbers between square numbers. Here is an example. 1 to the power of 2 and 2 to the power of 2. Now let's find the perfect square of both of them. The perfect square of 1 to the power of 2 is 1 and 2 to the power of 2 is 4. Now how many square numbers are there? 2. 2 and 3. 1, 2, 3. 2 and 3. Let's see another example. 2 to the power of 2 and 3 to the power of 2. Let's find this perfect squares. So yeah. 2 times 2, 4. 3 times 3, 9. So how many square numbers are there? 4 square numbers. 5, 6, 7, 8. Right? This is how we can find numbers between two non-square numbers or 4 non-square numbers or square numbers. Now let's find non-square numbers. The non-square numbers, which is one less than difference of two consecutive squares. So let's have an example. Now if we have now 9 and 16 as our example, and we need to find the non-square numbers. How do we find them? First we're going to take their square roots, which is 3 to the power of 2 and 4 to the power of 2. Now we are going to multiply 2 times 3, which is 6. 2n. 2 times 3, which is 6. 2 times 4, which is 8. 2 times 5, which is 10. 2 times 7, which is 14. This is how we are going to find non-square numbers between two consecutive squares. Pythagorean triplets. Have you heard about Pythagorean triplets? I guess you have learned Pythagorean theorem in the last class, which is grade 7. Now we're going to see Pythagorean triplets and square roots. So let's see an example. If we have 6 to the power of 2 and 8 to the power of 2. Now we're going to find the Pythagorean triplets of them. So this is 10 to the power of 2. This is your example. Now we're going to find the perfect square of each one and all. 6 is 36. 6 times 6 36. 8 times 8 64. 10 times 10 100. Now if you plus these both, what do we get as a result? 100. So 100 is equal to 100. So now we can conclude that 6, 8 and 10 are Pythagorean triplets. Let's see another example. 3 to the power of 2, 4 to the power of 2, 5 to the power of 2. Now let's find their perfect squares. 9, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Now if we add 16 plus 9, we get the result as 25. So 25 is equal to 25. What do we get the result? What is the conclusion? 3, 4, 5 or Pythagorean triplets. Now let's see how do we find a smallest member of Pythagorean triplet, which is 12. So let's take the as m, 2m, which is equal to 12. So we don't know what is m. We're going to divide 2m by 12. 2 by 12 is 6. Now when we find 6, we're going to take 6 to the power of 2 minus 1. We're going to find the perfect square. 36 minus 1, 35. We're going to add 6 to the power of 2 plus 1, which is 37. Now we're going to find the smallest member of 12. So we're going to do 12 to the power of 2 plus 35 to the power of 2 and 37 to the power of 2. Now we're going to do their perfect squares and we're going to add them and we're going to get the result as 1369 is equal to 1369. We can conclude that 12, 35 and 37 are Pythagorean triplets. Task sheet. Here's a task sheet for you. Let's see how well you can do this task sheet. Here are some questions that you can practice in your home and you can write your answers or share your scores with us in the comment below. You can pause the video to write your answers. We conclude our topic square and square roots. We will be doing the next in the remaining in the next video, which is the application of square and square roots to solve problems. I'm going to be doing it in the next video and I hope you like this video. Subscribe, share, comment and give us a like button. You can also, I would like everyone to share their scores of the task sheet as well as the pre-assessment in the comment below. So I will see you next time. Goodbye.